has found himself being hunted by a great white shark, and he caught it all on camera. Check it.
It began with a routine study along the Australian coast, just another great white shark tagged for research. But then, without warning, the shark disappeared. No signs of a struggle, no trace of the body. Only the tracking device, found later on shore, told a story no one expected. The data revealed a sudden rise in temperature, followed by a steep, fast dive into the deep ocean. Movements that suggested the shark hadn't died alone, but inside something else. There were no answers, only questions that deepened with every new piece of evidence. In a place where the great white is supposed to rule, what could challenge its dominance so completely and so quietly? What happened beneath the surface that day unsettled even the most seasoned marine biologist. Join us as we reveal the chilling creature responsible for eating a great white shark. The discovery of the great white shark. It began as a routine scientific study off the coast of Western Australia. In late 2003, marine biologists tagged a healthy 9-foot-long female great white shark to monitor its migration and behavior as part of an ongoing predator tracking program. These tags are designed to record water temperature, depth, and movement, and after a set period, they detach and float to the surface, transmitting data to satellites. For several weeks, the shark moved normally along the southern coastline, following patterns typical of other tagged sharks. Then, something extraordinary happened. Roughly 4 months after tagging, the device popped up on a beach in Australia. But instead of providing routine behavioral data, it revealed a terrifying event that baffled scientists. When researchers retrieved the data, they saw something that made no sense. First, there was a sudden spike in temperature. The shark, normally swimming in ocean water around 46 degrees Fahrenheit, which is 8 degrees, was suddenly exposed to temperatures of 78 degrees Fahrenheit, which is 25.5 degrees Celsius, a dramatic and unexplained rise. That temperature was far too high for open water at those depths. The only logical explanation? The tag had been ingested by a warm-bodied predator. Then came the plunge. Immediately after the temperature spike, the tag recorded a sharp descent, nearly 1,900 feet straight down into the deep ocean. The pattern didn't match a free-floating tag or scavenging fish activity. It mirrored the movement of a much larger, fast-diving marine predator. And then, curiously, the tag continued to move over the course of several days, before it was eventually excreted or dislodged and floated to the surface. To the team, this was more than a biological mystery. It was a direct challenge to the assumptions that scientists held about great white sharks. How could a 9-foot-long apex predator, the top of its food chain, be eaten alive? Initial speculation ranged from the bizarre to the mythical. Was there an unknown sea monster out there? A prehistoric predator thought to be extinct? Had scientists just uncovered the existence of some giant deep-sea creature that had never been documented? While those ideas caught the public imagination, the scientists stayed grounded. They began examining the most likely biological explanations. Was it another, even larger, great white shark? Or could it have been a killer whale, an orca, one of the few known marine animals that could rival a great white? But the tag's combination of data, temperature rise, vertical descent, and internal movement didn't line up neatly with any known predator. Each theory had holes, and no creature's behavior seemed to match what was recorded. Yet, the event had clearly happened. Something had eaten that shark and moved on with its life, as if nothing extraordinary had taken place. The case quickly gained media attention, becoming the centerpiece of the documentary The Hunt for the Super Predator, which followed the research team's journey to unravel the identity of this mysterious killer. public fascination exploded. After all, if something could eat a great white shark whole, what else was it capable of? What made this more chilling is that this wasn't a random mystery. It was backed by hard data, collected, recorded, and analyzed. It wasn't hearsay, myth, or blurry video footage. The predator had left a digital fingerprint, and the deeper the scientists looked, the more it pointed toward a shocking reality lurking just beneath the waves. At first, the idea that a great white shark could be eaten whole sounded like science fiction. But as marine biologists dug into the data retrieved from the 2003 incident, one possibility rose above the rest. The shark had been eaten by another, much larger great white. The first theory, great shark cannibalism. It seemed unthinkable. Great whites are apex predators, agile, solitary hunters that rule the oceans with speed, strength, and highly evolved sensory systems. They have no natural enemies once they reach maturity, or so most people believed. But the ocean has always been a place of brutal survival. And as scientists would soon discover, cannibalism among sharks is not only possible, it's shockingly common. Cannibalism is deeply rooted in shark biology. In fact, for some shark species, it begins before birth. In sand tiger sharks, for example, the largest embryo in the womb will consume its smaller siblings, a phenomenon known as intrauterine cannibalism. This ensures that only the strongest are born. It's nature's brutal way of preparing them for a life of predators and prey. Outside the womb, shark-on-shark predation is less common, but well documented. Larger sharks, especially great whites, tiger sharks, and bull sharks, have all been observed preying on smaller sharks, including those of their own species. It's not personal. It's opportunistic. A smaller, weaker shark becomes just another meal when survival is the only rule. In one documented case, researchers off the coast of South Africa watched a large great white bite another in half. Another incident off Mexico's Guadalupe Island showed aggressive territorial attacks among great whites during mating season, sometimes resulting in fatal injuries. These cases were known, but often viewed as anomalies. The 2003 Australian events changed that. The recovered tracking device told a chilling story. The shark it was attached to had been swimming normally, until the moment everything changed. A sharp rise in temperature, a steep descent. Then, for several days, movement at depths consistent with a large predator. When scientists compared the internal temperature to known marine animals, they found that it closely matched the internal body temperature of a larger great white shark. Unlike most cold-blooded fish, great whites are regionally endothermic, meaning they can warm certain parts of their bodies, particularly their stomachs, brain, and swimming muscles, to remain active in colder water. This ability allows great whites to regulate their digestion, hunt in colder regions, and maintain energy for long migrations. The data from the tag strongly suggested that the smaller shark had been swallowed by another warm-bodied predator, and the swimming patterns recorded afterward, slow, deliberate dives and ascents, also mirrored the movement of a very large great white. For researchers, this wasn't just guesswork. The movement data from the tag was compared to a database of known swimming behaviors from other large sharks previously tagged. The patterns aligned, and they didn't align with squids or other marine predators. Everything pointed to one conclusion. The predator was another great white, far bigger, and clearly more dominant. So, how big would this super predator need to be to eat a 9-foot great white shark whole? The estimated size? At least 16 feet long, possibly more. That puts it well within the known size range of the largest great white sharks ever recorded. Some individuals have measured up to 20 feet, though most are smaller. A 16 to 20-foot shark could easily overpower a 9-footer, especially in a surprise attack. This wasn't a battle between equals. It was a one-sided ambush. Scientists theorized that the larger shark may have attacked for several reasons: territorial behavior, competition for food, mating aggression, or simply because it was hungry. A smaller shark is a highly nutritious, high-fat meal. In the wild, survival often trumps species loyalty. The predator's location deep in the water column after the event also fits this theory. Great whites have been known to dive over 3,000 feet in search of prey or cooler waters. The recorded descent of nearly 1,900 feet is well within their capabilities, particularly if the larger shark was moving into deeper water to digest its meal undisturbed. This incident shook long-held assumptions about the food chain. The great white shark, often portrayed as the ultimate ocean predator, was now seen as a target, capable of being hunted, ambushed, and consumed by one of its own kind. This revelation not only expanded scientific understanding of shark behavior, but also deepened the mystery surrounding deep-sea ecosystems. If a 9-foot shark could disappear like that, if it could be eaten whole, what else might be happening beneath the surface, far from human observation? Scientists began re-examining other cases of missing tags, abnormal shark behavior, and sudden disappearances. What they found was a pattern. Other sharks had also vanished without explanation. And while not all cases could be confirmed as predation, the possibility of dominant great whites preying on their smaller counterparts was no longer considered rare. The mysterious disappearance and the data it left behind became the centerpiece of a documentary called The Hunt for the Super Predator, which followed marine biologist Dave Riggs and his team as they searched for answers along Australia's rugged coastline. What they found reinforced the theory of a cannibalistic great white. The documentary offered the first widely accessible look into this kind of predator versus predator behavior, captivating viewers with the idea that somewhere in the deep, there's always something bigger. While the theory of a larger great white shark devouring a smaller one fit much of the data from the 2003 disappearance, it wasn't the only explanation scientists considered. The second theory, the orcas. As more strange shark deaths began surfacing around the globe, many involving missing organs and minimal struggle, marine biologists turned their attention to another apex predator, the orca, also known as the killer whale. Orcas are not sharks. They're marine mammals, highly intelligent, highly social, and devastatingly efficient hunters. They travel in pods, communicate through complex vocalizations, and have been observed using coordinated tactics to take down prey much larger than themselves. While they primarily feed on fish and squid, certain orca populations have developed specialized diets, targeting everything from seals to large whales, and increasingly, great white sharks. For a long time, the idea that orcas could prey on great whites was speculative. But in recent years, that speculation turned into verifiable science. In 2017, 5 great white sharks were found washed up on beaches along South Africa's Western Cape. All of them shared the same disturbing injury: missing livers. In some, the heart or stomach had also been removed. The rest of the body remained almost untouched. What shocked researchers wasn't just the organ removal, it was the precision. These weren't the jagged tears of a typical predator. The incisions were clean, almost surgical. The killer, it seemed, had removed only the most nutrient-rich parts and left the rest. And in all 5 cases, there were no signs of a prolonged struggle. Local marine experts had a theory. The culprits were two orcas known as port and starboard, infamous for their unusual behavior and curved dorsal fins. These two had been spotted in the area around the time of the shark strandings. Scientists believe port and starboard had developed a specialized technique for attacking great whites, one that involved flipping them upside down to induce tonic immobility, a natural state of paralysis in sharks, and then removing the liver with a precise bite through the pectoral region. Shark livers are rich in squalene, a highly fatty compound that provides immense energy. For orcas, it's the marine equivalent of high-octane fuel. It's believed these intelligent hunters have learned to target the liver specifically to maximize gain with minimal effort. The evidence wasn't just circumstantial. Biologists found orca tooth impressions on the shark carcasses. Even more compelling, tagged sharks that had been lingering near seal colonies in South African waters suddenly fled when orcas arrived. In one case, great whites vacated an entire region for months after just one orca sighting. The fear response was so strong that even large, healthy adult sharks abandoned their feeding grounds. Similar patterns were recorded off the coast of California and Australia. In Monterey Bay, for example, great whites would regularly patrol the area during certain months, until orcas entered the scene. After just a brief appearance by a pod, the sharks vanished. The behavior was clear. The great whites recognized killer whales as a lethal threat and responded with immediate flight. Given this growing body of evidence, it's natural to wonder whether orcas could have been responsible for the infamous 2003 Australian shark disappearance. At first glance, the orca theory seems to answer a lot of questions. Orcas are one of the few predators capable of overpowering a great white. They are known to remove specific internal organs and discard the rest. They have the intelligence and precision to ambush sharks using specialized tactics. Their presence causes panic in local shark populations, suggesting a clear predator-prey relationship. But despite all this, when it comes to the 2003 cases, things don't quite line up. The biggest inconsistency lies in the nature of the data. The recovered tracking tag showed the shark being swallowed whole, or at least engulfed in a way that brought the tag inside another creature's digestive system. This is not how orcas typically consume sharks. As shown in the South African kills, orcas remove the liver and sometimes the heart, then leave the rest of the carcass to sink or wash ashore. They don't swallow prey whole, and they rarely consume the entire shark, especially a 9-foot one. Moreover, orcas are not warm-blooded in the same way that sharks are regionally endothermic. While their bodies are warm internally, the exact temperature recorded by the tag, 78 degrees Fahrenheit, which is 25.5 degrees Celsius, is more consistent with a shark's digestive tract, which can reach those levels when metabolically active. Then there's the matter of the descent. After the temperature spike, the tag was pulled 1,900 feet downward. Orcas typically hunt in shallower coastal waters and are not known for sudden deep dives post-kill. Their lung-based respiration system limits their deep-sea activity, especially when compared to large sharks, which are equipped to make dramatic vertical migrations. So while orcas are clearly capable of killing great whites, and do so with alarming precision, their known hunting patterns, digestive behavior, and physiology don't perfectly fit the data from the 2003 incident. Despite these inconsistencies, the idea of killer whales outsmarting and preying on great whites has captured the public's imagination. In many ways, it's more shocking than the cannibal shark theory. Orcas are often portrayed as gentle giants, stars of aquariums, symbols of family and intelligence. Seeing them as surgical killers flips that narrative on its head. This fascination has driven countless documentaries, articles, and online debates. Social media has helped spread dramatic footage of orcas flipping sharks or dragging them through the waves. In 2022, a drone captured 2 orcas chasing a white shark in the shallows, with the shark trying to flee as fast as possible. The orcas pursued calmly, methodically, completely in control. Scientists caution against painting orcas as villains. They're doing what any apex predator does: survive. And their ability to adapt their hunting techniques makes them some of the most versatile killers in the ocean. Part of the reason the orca theory persists in relation to the 2003 case is that it's dramatic, recent, and real. Unlike the cannibal shark theory, which is harder to witness firsthand, there is now mountains of footage showing orcas killing sharks. That's compelling. And there's a deeper psychological layer to it. We don't like to think of sharks as vulnerable. Sharks, especially great whites, represent primal fear, untouchable power, and raw instinct. The idea that something, even a charismatic marine mammal, can outwit and dominate them is both terrifying and awe-inspiring. So when a mystery like the 2003 shark disappearance emerges, and no clear culprit is identified, it's natural for people to lean toward the more familiar killer, one we've already seen in action. But scientific integrity lies in the data, and the 2003 data doesn't match the killer whale profile. No liver targeting, no shallow behavior, no surface-based attack. Instead, it reads like a clean, efficient swallowing event, followed by a slow, deep dive, behavior far more typical of another large shark. That doesn't mean the killer whale hypothesis is wrong in general. It's very real. It's just not the best fit for this particular mystery. Why the orcas can't be accurate. On the surface, orcas, or killer whales, seemed like the most logical explanation for what happened to the tagged great white. They're incredibly intelligent, brutally efficient hunters, and have been documented preying on sharks. In fact, in some parts of the world, great whites flee entire regions for months after orca encounters. But when marine biologists closely examined the data from the 2003 events, they started to notice several inconsistencies that began to cast doubt on the orca theory, at least in this specific case. Let's start with the thermoregulation factor. The tracking tag recorded a rapid spike in temperature from 46 degrees Fahrenheit, which is equal to 8 degrees Celsius, to 78 degrees Fahrenheit, which is 25.5 degrees C, at the moment the shark disappeared. That sudden increase suggests the tag, and likely the shark, was swallowed whole by something warm-blooded. Orcas do have high internal body temperatures due to their endothermic physiology, but their core temperature typically hovers between 96.8 degrees Fahrenheit, equal to 36 degrees Celsius, and 100 degrees Fahrenheit, equal to 37.7 degrees Celsius, significantly higher than the 78 degrees Fahrenheit recorded by the tag. So, if an orca had swallowed the shark, or the tag, the expected temperature reading would have been much higher. The inconsistencies was more than just a few degrees. It raised a fundamental question. Was the tag inside an orca at all? Then there's the depth profile. After the spike in temperature, the tag recorded a sudden and sustained descent to around 1,900 feet, approximately 580 meters. While orcas can dive to impressive depths, recorded up to 280 feet, 1,000 meters, they usually don't do so quickly or frequently. Their typical foraging occurs in shallower zones, and their deep dives tend to be deliberate and infrequent. What the tag recorded was a sudden, rapid descent, more consistent with the behavior of certain shark species, particularly large great whites, which are known for abrupt vertical movements in the water column. Moreover, orcas are surface hunters by nature, When they target sharks, they don't chase them into the abyss. Instead, they use coordinated attacks, often in groups, to exhaust and flip their prey upside down, a technique that induces tonic immobility in sharks, effectively paralyzing them. After incapacitating the shark, orcas surgically remove the liver with astonishing precision, often leaving the rest of the carcass untouched. But in the case of the 9-foot great white, no remains were ever found. No liverless corpse. No floating carcass. Just a detached tag that washed up on a beach days later. This suggested complete consumption, not the methodical dismemberment typical of orca predation. And that changed the tone of the investigation. Another red flag in the orca hypothesis was behavioral timing. Orca attacks on great whites tend to cause panic ripple effects. In South Africa, when a pair of orcas named Port and Starboard began killing great whites and removing their livers, researchers observed mass shark evacuations. Sharks would completely disappear from those waters for months at a time. Yet in the Australian case, surrounding sharks remained in the region after the disappearance. If orcas had been active predators in that area, marine biologists expected to see a similar reaction, an exodus of nearby great whites. But that didn't happen. The data suggested a localized, isolated event, not part of a broader pattern of orca hunting. There's also the matter of logistics. Orcas, despite being terrifyingly effective, are pack hunters. It's rare, if not unheard of, for a single orca to ambush and devour a great white whole without leaving evidence. Their predation strategy is surgical and group-oriented. The data from the tag, however, indicated a clean ingestion and solitary movement afterward, as though one massive creature had swallowed the shark and dove deep. Finally, there's the shape and nature of the event itself. If this were an orca attack, it would likely have involved a prolonged chase, surface splashing, and bodily trauma. The shark would have tried to escape, maybe breached the surface, and left a disturbance behind. But none of those signs were reported. Instead, the evidence shows a clean, almost stealthy disappearance, followed by biological data that fits no known orca pattern. All these anomalies forced researchers to reconsider. They weren't denying that orcas hunt sharks, far from it. In fact, orca predation on sharks is one of the most thoroughly documented phenomena in marine biology today. But in this specific case, the method didn't match the killer. The idea that a single orca snuck up on a 9-foot great white, swallowed it whole or mostly whole, dove 1,900 feet, and left no remains, all while showing internal body temperatures of only 78 degrees Fahrenheit, began to feel more like science fiction than a viable biological theory. If this was an orca, it wasn't behaving like any orca ever recorded. So what else could it have been? That led researchers back to one of the most unsettling possibilities. Another great white, far larger, more aggressive, and potentially cannibalistic. While rare, cannibalism among sharks isn't unheard of. It happens in the womb. It happens during feeding frenzies. And it happens when size differences become extreme. And in this case, it began to make more and more sense. The predator's body temperature aligned more closely with known great white physiology. The sudden dive and the movement pattern? Classic signs of a large, confident shark, asserting dominance in its territory. While the orca hypothesis captured public attention, it simply couldn't hold under close scientific scrutiny. The temperature was off. The method was off. The aftermath was off. And in a field where precision and pattern recognition are everything, those inconsistencies mattered. By ruling out the orca, researchers weren't claiming they had the answer, but they were one step closer to it. The evidence pointed to something large, something fast, and something capable of turning a 9-foot shark into lunch. And if that something wasn't an orca, it was likely one of the great white's own kind. The accurate theory. Once the orca theory was ruled out, researchers were left with a chilling alternative. The predator that swallowed the 9-foot great white whole body was another great white, but not just any great white. This one had to be colossal, aggressive, and possibly an apex among apex predators. In other words, a cannibal shark. Cannibalism in sharks isn't a myth. It begins before they're even born. Some shark species, including the sand tiger shark, engage in intrauterine cannibalism, where the first embryo to hatch inside the mother consumes its siblings for nourishment. But post-birth cannibalism, especially among great whites, is rare and poorly documented. Still, marine biologists have long suspected that larger sharks will sometimes prey on smaller ones, especially if they're in territorial waters or food is scarce. In this case, the temperature data, the depth profile, and the method of consumption all pointed toward a very large, great white shark as the predator. But just how big would it have to be to eat a 9-foot shark whole or in massive chunks? Experts estimate that to consume a shark of that size, the predator would need to be at least 16 to 20 feet long, possibly larger. While that's not unheard of for great whites, females especially can grow to those lengths. It's still an exceptional size. A white shark of that magnitude would weigh more than 4,000 pounds and be powerful enough to attack and disable a 9-foot rival with a single ambush. But what made this predator even more terrifying was how it hunted. The tagged shark didn't show any signs of erratic escape behavior before it disappeared. That suggests it never saw the attack coming. No fight, no flight, just a sudden vanishing into the abyss. This kind of ambush is typical of dominance-based predation, where a larger shark eliminates a smaller rival with overwhelming force, often not for food, but to assert control over a territory or mating ground. And it raises the question, how many of these supersized cannibalistic sharks are out there? And why don't we see them more often? The answer may lie in the way we track and study sharks. The oceans are vast, and the data we collect is still limited to a few tagged individuals at a time. Many of the largest sharks don't come near human activity, don't breach, and don't get caught in research nets. They exist at the edges, deep waters, remote feeding zones, migratory corridors far from shore. In fact, some scientists believe there's a kind of natural hierarchy among sharks, unseen but rigidly followed. The largest and most aggressive individuals dominate specific regions, forcing smaller sharks to adapt, move, or die. This would explain the abrupt territorial evacuations seen in places like False Bay when dominant predators arrive. And it would also explain why the tagged shark's disappearance didn't cause a panic in surrounding sharks. They may have already known that something bigger was in charge of those waters. Further evidence comes from tagging anomalies. In the years following the 2003 event, other researchers began noticing odd patterns in tag data, sudden drops, temperature changes, and signal loss, some of which bore eerie similarities to the Shark Alpha incident. While not as dramatic, these events hinted at a hidden world of shark-on-shark predation that science was just beginning to uncover. In some rare cases, shark carcasses with massive bite marks have washed ashore. The bite radius and depth suggest predators of extraordinary size, larger than any white shark officially documented. But the ocean doesn't give up its secrets easily. Carcasses sink, tags are lost, and witnesses are non-existent. Nature covers its tracks with brutal efficiency. The 2003 incident remains the clearest documented case of one great white likely killing and consuming another. And that alone has reshaped how marine biologists view the food chain in the open ocean. It's not just orcas and humans that sit atop it. Somewhere in the deep, other sharks enforce their reign, often violently and invisibly. It also reopens an ancient door to speculation about mega-sized sharks lurking in deep, cold waters. Not necessarily the long-extinct megalodon, but rogue giants that may not have encountered humans simply because they don't need to. If you're 20 feet long, 5,000 pounds, and rule your kingdom from 2,000 feet below the surface, what incentive would you have to come up? Of course, such theories remain controversial. Most scientists believe that white sharks top out around 21 feet, and there's no hard evidence for individuals beyond that. But nature has surprised us before. And the oceans, with more than 80% still unexplored, remain the last frontier for such revelations. In the end, the mystery of the great white that vanished was not solved with a new discovery, but with a chilling realization. The predator was one of their own. Somewhere beneath the waves, a monstrous shark, bigger, smarter, and possibly cannibalistic, had claimed its prey. No fanfare, no trace. Just a spike in temperature, a plunge into the dark, and a vanishing act that sent shockwaves through marine science. If you enjoyed this video, like and subscribe, and also click the next video shown on your screen.